All right, guys. Today we're going to be doing a little bit of implicit differentiation, and the reason why this is like a great and useful thing is because not always do I have my derivatives solved for y. Also, I'm not always asked to differentiate in terms of the variables that I'm given. So for in this example right here, we know that we're taking the derivative of y with respect to t. Since we're taking the derivative of y, that means that that y can actually derivate, but because we're doing it with respect to t, it does not cancel out, so it's not just 1. You're just left with that dy over dt. Same thing right here, you're still differentiating. So we take the derivative by multiplying by 4, taking the degree down, but because we're supposed to be taking it with respect to t, and what we did was we took the derivative of x, we keep those dx over dt's there. So let's look at this very first problem here and go over how I would start solving that. So I know I need to differentiate, and I need to find dy over dx. So I'm going to take the derivative of both of these sides here. The very first guy, we have 3x squared. Technically, so what we did is we took the derivative of x, so really that's a dx over dx, which just cancels out. So I'm going to erase that, but I wanted to show you that just so you see what happens there. Then we have a plus 3y squared. We took the derivative of y with respect to x. Those don't cancel, so that's why that stays. 6, and now we have a plus 4y dy over dx. Now if I'm solving for dy over dx, now we're just doing some basic algebra. So I need to move all my dy over dx's to one side, and I need to move all my other terms over to the other side. So let's put this, and let's kind of move this 3x squared over and move that 4y dy over dx over. So I get 3y squared dy over dx minus 4y dy over dx equals 6 minus 3x squared. Now we're just factoring out. So dy over dx gets factored out. We're multiplying by 3y squared minus 4y. And then just isolate that variable. And you are good to go. Now let's take it up a little bit. On this next one, we are going to be finding the second derivative. So we're going to have to take the first derivative first, and then we're going to use that information to input and find that second derivative. So very first thing, we have 2y. That's going to be a dy over dx minus, we're using chain rule here, so the derivative of x is 1, so 1y plus derivative of x stays here, derivative of y is dy over dx. The derivative of 8 is 0. I'm going to distribute that negative really fast, so I have 2y dy over dx minus y minus x dy over dx equals 0. All right, same thing as before. We're moving that y, and I'm actually just going to factor this out already. So I'm left with 2y minus x equals, that y got moved over, so we have a positive y here. Solving, so I'm just dividing by 2y minus x. All right, let's pause right here, and I'm going to rewrite so that's nice and neat. dy over dx is going to equal y over 2y minus x. Now let's take it to our second step, which is I need to differentiate twice. So when I do that, I automatically, I'm going to leave this here. I'm going to move all of this. I automatically know that by taking the derivative again, I'm going to get d2y over dx squared, so the second derivative with respect to x, and that's going to be, I'm going to have to be using quotient rule here. So remember, we're doing the low times the derivative of the high, 2y minus x times derivative of high, which is dy over dx, minus high, that's y, times the derivative of the low, so 2 dy over dx, minus 1 over the low squared, so 2y minus x squared. Now this is not beautiful, but we do need to start substituting because I know that dy over dx does have a value that I can plug in. That way I can keep that d2y over dx squared isolated and kind of out of the way. So let's get that substitution going here. I know that d2y over dx squared is going to equal, we have 2y minus x over y 2y minus x minus y times 2. Lots of parentheses going on here. I had to make sure that was good. That's all going to be over 2y minus x squared. So let's start doing some canceling because we can. This is going to go away. And after that goes away, I'm just going to leave this alone for now, and I'm really going to be working with this right-hand side of the numerator. So I'm now left with y minus, and I'm not touching anything. I'm going to distribute this y right here. So I'm going to have a 2y squared over 2y minus x minus y, and we have nothing. So I'm going to get a common denominator. So 2y minus x, 2y minus x. I still know what that's all over, so I'm going to continue this on all over. I'll just write it just so it's there. Now, let's get this going up top a little bit more. So I have a y minus 2y squared minus 2y squared minus x squared. Sorry, plus xy. And that is all going to be over 2y minus x. Now we can probably see where this is going. We're going to need a common denominator, and I'm going to get the numerator all combined to be one term. So I'm just still working with the numerator. I still know that 2y minus x squared is down there in the denominator. So I'm going to multiply this guy by 2y minus x over 2y minus x. So that y gets distributed. I'm left with a 2y squared minus xy. These guys cancel. So I have another minus xy all over 2y minus x. And then instead of dividing by that 2y minus x, I'm going to multiply by 1 over 2y minus x squared. And now when I combine all my like terms, and I just realized that I made an error in the answer key, so just check this over. This should be in the numerator, 2y squared minus 2xy, or 2 times y squared minus xy, over 2y minus x cubed. And we can just leave it like that.